We will now talk about proving trig identities. And the first thing that we need to do is establish some background. During this video, you're going to want to pause the video so that you can write down information in your notes. The first thing we need to do is establish the basic identities that we need to know. The first of these identities are the Pythagorean identities. The first Pythagorean identity, you have sine squared plus cosine squared is equal to 1. And I have written down two alternate forms for this same identity. You have the second trig identity, which is 1 plus tangent squared equal to secant squared. And I have also written down two alternate forms. Pause the video and write down these two identities. There is a third identity. The third Pythagorean identity is 1 plus cotangent squared equals cosecant squared. There's two alternate forms for these. Pause the video and write down this third Pythagorean identity. The next of the basic identities that we need to know are the identities that involve tangent and cotangent. The first is that tangent of x is equal to sine x over cosine x. The second is that cotangent of x equals cosine x over sine x. Pause the video and write these two identities down. The next identities that we need to know are the reciprocal identities. The first is that sine x is equal to 1 over cosecant of x. Alternately, you have that cosecant of x is equal to 1 over sine of x. The second is cosine of x is 1 over secant of x. You also have an alternate form for that identity. The third, you have tangent of x equals 1 over cotangent of x. You also have an alternate identity there. Pause the video and write down these three identities. The next thing that I would like to discuss as far as background for proving trig identities is some basic techniques. Now, no one of these techniques is meant to necessarily be a fast and true rule, but it will at least give you somewhere to start. Okay. First thing, start with the uglier side of the identity. There are certain problems that one side is obviously more complicated and more ugly than the other side. Usually we will want to start with that side. It's easier to simplify something that's complicated than it is to build up something that's simpler. The second thing, once you've picked a side, work only on that side. Do not move terms over the equal sign. So in other words, with our usual equation, we can add and subtract terms over, multiply and divide, sides by the same value. You do not want to do this when you're establishing an identity. What you want to do is you pick one side, you work with that side until you have that it's equal to the other side. Next, one idea is sometimes you can rewrite the trig functions that you've been given in terms of sine and cosine. The next thing, sometimes you can combine like terms. Sometimes you can also combine fractions. Usually you'll have to find a common denominator to do this. Another technique is sometimes you can factor and cancel if the identity is a rational expression or a fraction. We're not used to factoring most of the time with trig, but we will learn how to do this. Okay, the next thing, you can perform operations. Add terms together, subtract, multiply, or divide. The last technique that I'll talk about is for fractions. If you have a fraction of the form some expression over 1 plus a trig function or 1 minus a trig function, you can start by multiplying both the numerator and the denominator by the conjugate of the denominator. So for example, if you're given something on one side of an identity such as secant x over 1 minus tangent x, you can start by multiplying that given expression by the conjugate of the denominator. You look in the denominator here and you see 1 minus tangent of x. The conjugate means that you keep the terms but you change the sign on the trig function. So the conjugate of 1 minus tangent of x is 1 plus the tangent of x. And by doing this multiplication, this a lot of times creates a Pythagorean identity in the denominator that you can then go and rewrite. This concludes the lesson on techniques and trig identities that you need to know for solving or for proving trig identities.